This next equation is called a literal equation because we're not solving to get just a numerical solution. We're solving for the variable a, which is going to end up being an expression containing the other variables. First thing I want to do is clear the fraction by multiplying through by 2 on each side. This is going to give us 2s is equal to n times the quantity 2a plus n minus 1 d. The second thing I want to do is to distribute the d inside the bracket on the right. 2s is equal to n times 2a plus nd minus d. Since we cannot combine like terms inside the bracket, let's distribute the n through to each term. This will give us 2s is equal to 2an plus n squared d minus dn. Okay, there are no more parentheses. Now it's time to isolate our variable. The a we're trying to solve for is in the 2an term, and so the other two terms need to be removed and brought to the other side. This will give us 2s minus the n squared d plus the dn equals the 2an on the right hand side. And please forgive me for not aligning my equal signs here. We want to isolate the a by itself, which means we need to divide off the 2n on each side of the equation. This will give us 2s minus n squared d plus dn all over 2n is equal to a. Since this expression on the left cannot be simplified, this is one way of writing our solution set. Now, however, up on that line above, we might not have chosen to divide the whole left side by 2n. Instead, we might have chosen to divide each term by 2n. Let's do that right now. This would give us 2s over 2n minus n squared d over 2n plus dn over 2n equal to a. If we had gone this route, we would have been able to simplify within each fraction. And we would have written our solution as s over n minus nd over 2 plus d over 2 is equal to a. Sometimes when we're solving literal equations, there are multiple forms of the answer. And in this case, both of these are equally valid.